Hi all, welcome to Learn Code Repeat. So today we'll be looking at the day 5 of the September challenge. Let's look into the problem. Today's problem is all elements in two binary search trees. So they have given two binary search tree and we have to return a list containing all integers from both the trees sorted in ascending order. So what does this mean, right? A binary search tree is basically a tree where the left child is smaller than the parent and the right child is greater than or equal to the parent. So that's the property of binary search tree, right? And also, if you traverse through the binary search tree in order way, right, then you can list down all the sorted elements, right? So this problem is listed as medium level difficulty in LeetCode, but I think if you know traversal of BST, this can be a easy problem. So let's see how we can traverse the BST. Okay, so let's see this example, right? So we have 1, 3, 4, 7, 8, 9, and this is represented as a tree, as a binary search tree. Here 5 and then 3 and 8 are the children. Again of 3 there's 1 and 4 the children, 7 and 9 the children. So if you see, all the elements to the left are less than the parent and all the elements to the right is greater than or equal to the parent, right? So that's a binary search tree. So to find out the ascending order of elements in binary search tree, we only need to do a in-order traversal. Traversing a binary search tree can be done in three ways. So one is in-order, second is pre-order, third is post-order. So what does that mean? It means that so given a tree with a root, left child and right child, so when do we refer to the root element? Whether we refer it first and then we refer to the left and right, or we refer first the left, then root and then right, or we first refer the left, right and then the root, right? So when does the order of the root element comes into picture? That dictates whether it's a in order or a post order or a pre-order, right? So when I say in order, it means that it should come in between. So first it will be my left, then my root and then my right. So this is in order. So here if you have given a binary search tree and if you traverse the binary search tree in order and if you try to print the root element or the current element of the tree, you will end up printing the values in ascending order. So let's see how, right? So here I have just mentioned the steps. Traverse first the left node, second the middle node, third the right node, right? So what does it mean is given the root, right, given the current element, we'll first we'll have to traverse the node dot left, right? So what I'm doing is I'm doing a recursive call and doing the node dot left. If I so from 5 I come to 3. Now again from 3 I will check whether there is a node dot left. I'll again traverse left. So I have to do a check, right? So there will be base condition of if node equal to null, then return. Okay. Else I'll traverse this first left node. Now I said I have to print, right? So I'll print node dot val, which is my current node. So when I'm traversing, right, so I'm traversing to the left. So from again left I'm traversing to the next left. Now if this next left is null, right, it will return back, right? And then I have to print. So I'll print. So this printing of the node becomes my current node. I'm printing my current node. So first I'm traversing to the left of my current node, then I'm printing my current node, and then again I'm traversing to the right of my current node. Okay, so again I'm traversing to the right of my current node. So these are the three steps that I mentioned. That's it. That's the only 3 lines of code or 4 lines of code, right, that you have to do for traversing. So the output of this will be basically it will print the values in ascending order. So let's say this is the tree, right? So from 5 it will go to 3, again from 3 it will do a left and it will come to 1, there is no child for 1, so it will try to print. So first it will print for 1. Now after printing 1, it will try to print the right of 1, right? So there is no child, so it will return back. It will return back to 3. And then from 3, it will print the current value of 3. Okay, and then it will check for right of 3. So again it will go to here, and that means the 3 child is 4, left of 4 is null, so it will return and it will print the value of 4. So here it will print the value of 4. Then again it will try to do a right of the current node, which is 4. There is null, so it will return, and then it will go back to 3. Okay, so that means this is also completed for 3. Now it will go back to 5 and it will print 5. If you see the order, if you observe this, it's printing in ascending order, right? 1, 3, 4, 5. So again when it goes to 5, so it started with 5, right? So now we have covered all the left side of 5, right? Now we will cover the right side. So we printed 5, then we'll go to the right side of 5. Right side of 5 is 8. It will come here. What is the left of 8? It will call this node.left for 8, 7. It will go here. Then again it will call node.left for 7. It will go into this traverse again, and it will return a null, and then it will try to print 7. So here it will print 7, and then again it will try to do a right of 7, which is null. Then it will go back to 8, and it will, so here left of 8 is done, so left of 8 is done, and it will try to print 8 then, and then it will go to right of 8, and the same loop will happen for right of 8, which is 9, and it will then print 9. So if you see, it's printing everything in ascending order, right? So if we go back to our question, right, the ask for the question was that given two binary search tree, return a list containing all the integers from both the trees sorted in ascending order. So we know now, given the binary search tree, how to sort it in ascending order, right? Or at least how to print, right? So here, instead of printing, I can pass a list, and I can just add the value into the list, right? So it's just a replacement of, instead of print, I can add the value into the list. So now once we have the list populated, right, let's say I'm using two lists, one for this, right, one for this tree and one for this tree. So after the traversing code, if I call, I will have two lists populated in ascending order. After that, it will be simple merging operation of two lists. It will be kind of a merge sort, where we have now sorted a list and we just need to merge it. So let's try. Okay, so first I'll define my traverse method. I'm using Java here. So I'll need the node, and I'll need the list, okay, where I need to store the values. So the base condition will be, if node is equal to null, return it, and then I'm calling the traverse again for my left node. It's in the list. So this is in order, right? First left, then the current node. So for the current node, I'll do list.add node.val, and then once the current node is done, I have to do the right node. So this will give me, or this will populate the list with the values of the tree in ascending order, right? So here, so I have defined two linked lists, list 1 and list 2. So first I will traverse the root 1 and populate list 1. Similarly, I will traverse root 2 and populate list 2. Okay, so now list 1 and list 2 is populated. Now once I have both list 1 and list 2 in ascending order, the values are populated, right? I just need to loop over this thing, right? So what I can do is, while not list1 dot is empty, and or instead of and, it should be or, because it can have different sizes of elements, right? Both the trees, right? So I'm using or list2 dot is empty. Okay, so I've defined array list of result and with the size, and here I'm doing if list1 dot get first is greater than list2 dot get first, then result dot add list2 dot remove first. Else result dot add list1 dot remove first. Now what am I doing here, right? Why I've used linked list and why not array list for list1 and list2, right? So if you see, if I do array list, right, I cannot use get first and remove. I can use still get first, but I cannot do a remove first, right? What it means is basically if I remove some element from array list, there will be a shift of all the elements in the array, and that will take more time, right? So for each while operation, I'll be doing O of n. And if I don't remove it, right, that means that till the time I am forming this result list, the list1 and list2 elements will still be in the memory. So imagine that if node 1 is having 10,000 elements, or root 1 is having 10,000 elements, root 2 is having 10,000 elements, and the result will have 10 plus 10, 20,000 elements, right? So till the time the result is formed and till the time the program executes, there will be around 10 plus 10 plus the final 20, so around 40,000 elements in memory, right? And if we don't have enough memory, we can have a out of memory error, right? So to have or to utilize the memory properly, what we have done is we have used a linked list, and linked list has the get first and get last method where it provides you access to the first and last element. And since it's linked list, removing of the first and last element or even the middle element is just O of 1 operation, right? There's no shifting involved here. So that's the reason why we have used for list1 and list2 linked list. For the result, array list is fine because we are just adding the elements in the list. So whether you use array list or linked list, anything is fine, right? Now this if condition is valid if both the lists are not empty. What if one list becomes empty? Then we have to fill up the other list with the remaining element, right? Or the result with the remaining list element, right? So that's what we will do here. And I think that's it. Once we have gone through the whole list, so here again to go over, we are first traversing through the tree node and populating the list1 and list2. We are using inorder traversal, and so the inorder traversal will be O of n because we have to find out all the elements of the tree, right? So it will be O of n, where n is the number of elements in the tree node, right? So if both the elements are having different number of elements in the tree, then it will be whatever is the max number of element in the tree, n will be that value, right? And once we have that, then we are having the result array, and we are just comparing the first elements of list1 and list2 because we know both list1 and list2 will be in ascending order. So we are just comparing which one is smaller and adding the smallest element in the result list. Okay, so once we add that, we'll do a while loop till both the lists are empty. Okay, that's why we have used a or condition here in the while. Until both the lists are empty, go over in the while loop, and then finally we return the result. Okay, so the final complexity of this will be O of m plus n, where m is the size of this root 1 tree node and n is the size of root 2 tree node, right? Because at the end we have to populate the whole result, right? So that will be the final complexity of this algorithm. Let's submit this and see whether it runs fine. Okay, so this is matching. Let's submit this. Okay, so this got accepted. Okay, so similar approach can be done in Python as well. I've already written the code to save the time. So let's go through this. So we have defined the traverse method in Python, where the logic is same, where we are traversing in order, and I have the list, and I'm appending to the list the root.var. So it will have the list in ascending order. So there are two lists, L1 and L2. We are traversing in order, populating the list. Once the list is there, we have the result defined and going over the while loop and populating the result using the same condition in Python, right? If L1 and L2, both the lists are not empty, then compare the first elements in the list and populate the result accordingly. If else if only one of the list is non-empty, then populate the result accordingly. Now, one point is that I want to mention is in both Java and Python here, you can, instead of doing this way, you can directly use the sort method, which will do the same thing. But since it's an algorithm video, right, we have mentioned it in as a while loop, and even in interviews they will expect that you should not use the sort method, the inbuilt library, and you should use similar fashion of merging the two sorted array, right? So I've just showed that method here. So that's why I've used while loop here. Let's run this code, and okay, this looks fine, and let's submit. Okay, so the Python code is also accepted. Thanks all for watching my video. If you like my video, please like, subscribe and hit the bell icon. Thank you all.